This is a quick update to my filter. I've built a small alarm. This is a dollar store window entry alarm thing, little magnetic reed switch that I've converted to work as a moisture detector. Yes, you'll hear this beeper, this buzzer later in the video, so guard your ears. Another update to this unit is somebody suggested that I use wing nuts, which is a good idea. It makes servicing this a lot easier. Actually, I'm not going to change the filter right now, though. Since it's so easy to get in there, and I just back this one off a ways and leave it sit. I was going to hack it off, but it's kind of neat. I can back it off, let it sit there, swing the cover open, change the screen that gets dirty the fastest, which is usually the final screen inside there. So I find if I clean that screen a couple times, well, actually I clean both screens while I got it open, I let the sack go. I'm using those nylon strainers. I let them go 2 or even 3 rinses of the screens before I change a new sock type thing in there. This is a dollar store item. It's actually worth the batteries. You know, the cost of the batteries alone are worth $1 pretty much. So it's a pretty cheapy item. I want to see if I can use this and modify it to make a water alarm out of it. So first of all, I want to open it up, see what's in here. I know I got one of these sitting around somewhere that I haven't used yet. I just bought a fresh one anyway. And what I'm going to want to do is get rid of the magnetic switch and put in a electronic, moisture detecting switch instead. It's going to be super simple. Let's see if I can get the code here. So go this way. Fairly obnoxious. This is going to be for my windshield, for my filter for my wash machine. So when the filter starts to overflow, hopefully that'll get my attention. Took the batteries back out. I only see one screw. Phillips jeweler style screwdriver. And there it is. So an integrated circuit that's been potted right on the board. Little piezo. This, I guess, is a capacitor. Maybe it's a coil. Not much to it. Where's the magnetic switch? Well, I just did some real off-the-wall calculations. I'm going to use a Darlington just because it's what I got around. I got transistors around. I don't have a FET around, which is something I should probably use instead. I know my friend John made a similar project like this a couple years back on his old channel. He used a FET. Anyway, I'm going to use what I got. And I'm kind of guessing at a lot of these voltages. I just wanted to get in the ballpark, and then I'm not even going to use my result anyway. But if I grab some transistors off the shelf, if they have a gain of 50, well, in a Darlington 2500 would be the gain of the Darlington. If the gain is a 20, which would be really low ball number, then at least a 400 gain. So I was thinking 10 milliamps to run this buzzer, probably at the most. these batteries might be able to do 20 milliamps for a real short period of time, but and again, I'm going so rough with these numbers, and I'm using such a low gain to calculate that I can be off a little there. Then I've subtracted the voltage that's going to be lost through the Darlington. Probable voltage loss of the circuit, maybe 2.1 volts left, divided by that current, 84. So I'm going to probably use like a 10 kilo ohm though, because I got to allow for resistance for the water too. So I got to keep it fairly sensitive. I just want the resistor to help. I could probably even go without a resistor here. So a very simple circuit. And I'm going to fit them right in this board and in place of the existing sensor, and then run 2 wires up the side. Need about a foot of wire, a little more than a foot of wire. And the sensor itself will be nothing but a couple wires close together. Well, looking at the circuit a little more carefully, I'm trying to figure out what I can of it, since a lot of it's just under a blob. But this is actually a transformer. This top piece here, it's not my sensor. My sensor for the there's no read relay in here, like I thought there might be a read switch. These 2 little wires on the side here, on the right side of the board. Somehow that's the magnetic sensor. I have no idea. Whatever it is, it's very brittle. I tried to get my fingernail underneath it and tug it up a little bit, and it just snapped right in half. So I hooked a wire up to where the magnetic sensor had been, whether it's a read switch or whatever it is. Apparently the switch was normally closed and only opened in the field of a magnet. Because when I had a wire attached to it, I had to put a short on the wire to get the beeper from stopping to go. So it's kind of opposite the way I really want it to be. And I couldn't just put my little circuit I put before, my little, I was going to put I soldered 2 transistors together in a Darlington. I was going to put them right across where the sensor had been. Well, that's not going to work. So instead I just put it in series with the power for the whole circuit and left these open. And that works. Lick my fingertip. So there's my water sensor. And there it is, all assembled. Kind of a tight fit with the 2 transistors, but it got all back together. If I could have a transistor that was a single Darlington or a FET, would have been a better match. I didn't use a resistor at all. There's not enough current here to damage the transistor. Alright, so now I've stuck the, used the double stick tape that comes with it, stuck it onto the side of the filter. I was going to put it in the cover, but that's too much action for the wire to be moving all the time. I've got a pretty stiff boot. If you had an inner tube like I suggested, it'd be a little easier, but jammed a screwdriver way under there. I'm going to put it up here. When it's backed up enough where it starts building up water pressure in here, it'll go off. We'll see how this works. Okay, so that's about where I want that. Pull the screwdriver out. Alright. Well, I'll have to see how this works. I didn't clean this thing out to see if it would backflow in a laundry load or 2. Well, I didn't have to wait very long. And yeah, water went over the top, so it definitely needs changing. And the alarm did go off. Now, if only I had the switch working on the side. The board's not in here very well. Oh, there it goes. The board's not in there very well. I got the transistors, I should have laid them down flat, one at a time, instead of doubling them up first. If you're making your Darlington, you know, make them so they're like flat across the top of the PC boards, not bunched up like mine were. So this PC doesn't really fit this case correctly. So I'm having trouble keeping the off switch working right. It's not, board's not on its mounts correctly. Anyway, so don't do that mistake if you make one of these. But that's easily avoided. So basically I just put a Darlington, which is 2 transistors, no resistors, nothing else, just 2 transistors, in series with the noise making circuit. I didn't use the contacts. I broke the contacts playing with them. So that's it. It worked. I'm experimenting with what to do with the tips here. At first I just took this straight zip cable and didn't even break the conductors apart. Stripped off about 1/16 of an inch. And that's almost too sensitive. This here is spread maybe an inch now. And that's even going to be super sensitive. My skin isn't even wet anymore. So it's still plenty sensitive. I may end up even spreading it more and experimenting, but this should be good for now.